Hey everybody, I'm back. So as I was watching my recording and getting ready for the next video, I realized that there's a whole nother way to do this. Now think about what we just did. So the structure of the data has tags. We just want the elevation and the time. So what I did with the track point method and then finding the children of the track point method, while it was a nice way to expose the sort of nested structure of the data and accessing nested things using Beautiful Soup, might have been a little overkill. So let's see if we can make it a little more concise. So I'm just going to say elevations is equal to soup.find all, what was the tag called? Ellie. And I'm going to say times equals soup.find all time. All right, so now I just got a bunch of these things. All right, so remember what we can get we can easily get the text of the item, right? So let's clean this up, list comprehension style here. I'm going to say x.get text for x in. And I'm just going to copy and paste that again and then change the name of the tag that I'm looking for at a time. Bada bing, bada boom. And make sure it looks good. Spelled it wrong. Not elves, elevs. Okay, that's a string. Let's see if we don't break it by calling float. That looks good to me. All right, so now we have two objects. We have two lists. And how do we get them together? We could, do something silly, but let's just make sure they're the same lengths, right? We kind of assume that we would have an equal number of elevation points and time points. Let's just do a real quick check. All right, ooh. Why do we have 219 times? Let's take a look. Search for time. We got 220. Oh, because the first time is the main time, so we don't want that. All right. So let's do something sneaky and just take it from the first item through the end. That's so sneaky, but it's okay. 219. What do you think about that? All right, good for us. Now we got to combine these things. So if you don't know much about Python, we're going to learn about zip a little bit here. It's kind of a cool thing. So we're going to say pairs equals zip elevs times. And now we have pairs. So you have these, it's a list of tuples. And that's quite nice. And we can essentially go back to this point now. And let me see if I can call df1 equals pd data frame from records. I don't know if it's going to bark at me or what. But yes, and that worked out just fine. Notice that when I used the dictionary up here, I specified the key and the value, and it was nice enough to read in the column name based on the key, and so on and so forth there. So with this, we need to sort of manually say declare the columns. We can just use a list. We can say elevation, time, and just make this a little compact here. Bada bing, bada boom. So that is interesting. It doesn't really matter which one we work with. I'm just going to work with df because I will keep forgetting to write df1 and I will screw it up. So just before we move on, just some quick methods, and we're going to have to deal with this time object soon. But some quick stuff. Df shape 219. If you want to inspect something, say the first row, you can do that. Then I can further specify time. And this is just Unicode, right? So that's an easy way to access different parts of the data frame. A lot of ways to kind of summarize different things. So df describe starts to sort of give counts, unique, tops, frequency. It depends on the data type though. So if this was more numeric data, it might output some statistical summaries of it. And another important one as you're kind of debugging the setup of the data frame is DFD types. Elevation should be a float. Let me see if I can. Well, here's another thing. So right, and we're working with. We didn't convert that to a float, but that's D1. So sorry. There we go. So df describe, since it has a float object in it, because I converted it to a float in that list comprehension, it does give me summary statistics about the elevation here. Let's do something quick about operations here. So I'm going to say elevation feet, and we're going to make a new column, and we're basically going to apply a lambda function in place to another column. So I'm going to take the elevation column, this guy, elevation. I'm going to map lambda x is an arbitrary sort of convention there, and I'm going to say x times, what was it, like 3.10 meters to feet, 3.28. So 3.28. And df1 head. There we go. So now I got my elevation in feet. Another quick one. Yeah, you know what? I'll pause right there. I think that was a good introduction to zip. Let me show you one more thing with zip. Let's say I had these things again here. Let me make a new cell. Now I manually kind of zip those up, right? I called zip elevs times. You can unpack things in a list with the star. So what that does is it treats the items as sort of iterables that it unpacks. It's kind of hard to explain, but you get used to seeing it. So if you had a list, I made a list that was kind of pointless. I could have just written with much less code this, but you know, you may find situations where you already do have a list and you know you want to sort of kind of unpack it and zip over it that way, and that's a shorthand way, just using the asterisk or star operator there.